All right, welcome to math class. If you notice this is a recording, that's because we're practicing currently for what it's going to look like with a sub here. So basically what's going to happen is when you have a substitute's going to have a movie and it'll be something that I recorded. The recording will be our screen, just like normal. So you guys have a warm-up. As we go through the warm-up, I'm going to pause this. That'll give you enough time to watch. Do what you need to do for the warm-up, and then we will continue on in a couple of minutes. So hopefully everything turned out well for the warm-up, and I didn't go too fast through that. So think about when a plus 3 equals an odd number and when a plus 3 equals an even number. All right, well, write three values you could substitute in for a to make a plus 3 an odd number. So we're going to work on a first. So because we're working on a first, we needed any values to add to a plus 3 to make an odd number. Hopefully you came up with some values. If we want it to be odd, and that is key on this, we want it to be odd. We are going to have to choose values that we can add to 3 in order to keep it odd. So we're going to add a value. You could have chose 0. You could have chose 2. 2 plus 3 is 5. 4 would work. 4 plus 3 is going to give 7. And then that kind of continues on. So hopefully you came up with some values to create an odd number. And remember that odd numbers are not divisible by 2. The next one then asks for an even value. So you needed to be able to add something to a plus 3 to make an even value. To do this, you could have chose 1. You could have chose 3. Could have chose 5. So notice this happened to be odd numbers. So if I chose an odd number to add to 3, 1 plus 3 is 4, 3 plus 3 is 6, 5 plus 3 is 8, and so on. All of those values will make it to be an even number. And remember that that is a number that is divisible by 2. And then the last one, write 3 values you could substitute for a to make a plus 3 a number that is not a whole number. Now I have a feeling that this will be the one that we struggled on. If you struggled on it, we just want to focus on what's happening there. We don't want a whole number. So remember when we're looking at something, and I guess an image is sometimes the easiest way to think about it. If we're trying to create a whole number, you can just kind of think of a pizza. If we have a pizza, you have one whole pizza. You're wanting to add some value to make it to where this thing's not whole. In this case, a plus 3 kind of throws us off a little bit, but a way of interpreting that would be I don't want a whole image, I want a part of an image. A part of an image could be 3/4 of a circle. So if we ended up having something, and I'm going to add in some quick lines here. If only that one portion had been filled, right, just this side, we wouldn't have that whole thing. And that's really what we're looking at. So in order to make it to where it's not a whole, you guys had unlimited amounts of things that you could have added in there. Me personally, work smarter, not harder. One of the quickest values that students tend to forget about is 1/2. So 1/2 added to 3. When I take 1/2, I add 3 to it. I end up getting 3.5. 3.5 would be a way of writing that if you wanted, or 3 and 1/2. Just by adding that half in, we made it into not a whole number, because 3.5, again, if you went back to the image thing, we would end up having 3 of these, right? Clone, clone. We now have 3 of those. And then you'd also need one more that we were only going to 1/2. So 3. We'll add in some color here. Boom, boom, boom. And then our 1/2 one would only be half of that, and I don't think that this coloring thing would work. Yeah, I didn't think so. I apologize for that. Learning the system as we go through it. So we'll go back to the pen. We'll change our color to blue. Again, 3.5, then 3.5, and it's just adding in that half, which means if we could add in a half, you could also add in a quarter. If you added in a quarter, 3 plus 1/4, 3.25, any of those values, you just needed to come up with 3 different values that when you add to 3, it creates not a whole number. So, for example, 1/2, 1/4, 3/4, 5/8, whatever it may be. You could have also done a decimal, so 0.5. That would be the sense of thinking of money. If you took 0.5 and added it to 3, you get that same thing of 3.5. So hopefully you came up with something. If not, you're writing down some notes. And remember that this style of question will show up on the quiz. You need to be able to understand what had just happened to make not a whole number. Okay, yesterday we didn't get to our classwork. You are going to get 9 minutes. 9 minutes to finish this. That's probably 5 minutes too long. If you notice, you should have done this last portion on Friday. So I'm going to pause the video now. You get 9 minutes to complete this. Okay, you should have already checked your answers. On a day typical with subs, we won't be able to ask questions typically. I mean, you could ask a little bit with Mrs. Ortman or to the sub, but we'll end up going over all class assignments when I return. So know that anytime that you have classwork, if I am gone, we won't go over the answers until I return. So it is your job to check the answers online. That's going to be big. So this was yesterday's. Our goal today is changing. Our goal is to use conventions for using, to use appropriate conventions for using numbers and variables and expressions. This was yesterday. So yesterday we talked about algebraic expressions, how to substitute, and also a variable. Today we are going to talk about conventions. So I need you to add somewhere in your notes. You need to put this in the notes again. A convention is an agreed upon way of doing something, and we're going to pause the video and we're going to have a brief discussion on what some conventions in everyday life are. So this is just things that are basically norms of everyday life or an agreed upon way of doing something. So you can pause the video now. So hopefully for your convention, you came up with some idea of what conventions are. The first one that comes to my mind is, what side of the road do you drive on? That was the first thing that came into my mind when it comes to conventions, and that would kind of even go for walking up and down the hallways. Just some basic things that are everyday life, and it's agreed upon way of doing something. You could also state when to wash your hands would be another one. That would be something to think about as a convention that is agreed upon for life. In this case, we're looking at math class, and some of our math class conventions are the following. You don't need to write this down, you just need to see what's going on. Conventions for multiplication, when we're looking at multiplying. So this one is for multiplication. When we're looking at multiplying, you need to understand that we don't put the dot always. If two things are directly next to each other, they are multiplying. You may put the dot, but as we go farther and farther in math, I don't want to see the dot. It's 8 in. Something else to think about when we're writing these, it is not in 8. I apologize that my handwriting is kind of sloppy on this. This is because I am writing on the computer. So it's never going to be in 8. Same thing here, m in. And then this last one is probably the one that I want you to focus on more than anything else. This guy. So this one is getting multiplied, and a lot of students don't realize what is getting multiplied. If you had me in the past, hopefully you recall, there is a value always in front of the number. So in this case, it's exactly what you're reading, you just would never put it. If we were to look at that, we have 1 in on the page. Like if we were to say, hey, how many ins do you have there? Your statement would be 1. So that means this is 1 times in. This one's a big one. You have to remember that one. So if you are going to write something down, when we are talking about 1 times in, we don't write 1 in. You guys will just end up writing in. Conventions for division. If you notice, all of these are fractions. We don't use the division sign like this very much anymore. Almost always it's going to be a fraction, so get used to seeing fractions, and our fractions are going to be reduced. So make sure we know how to write those. Again, we're not using that division sign anymore. Instead, we're going to write them as fractions. Example number 1. Okay, if we have each dog having 4 legs, Can you calculate how many legs there are if you know how many dogs there are? And most of us could come up with this. It's just simply taking the number of dogs, 3 dogs, 1, 2, 3 dogs, and multiplying it by 4 legs, assuming that they still all have 4 legs. Boys, I know that that was the number one thought on your mind. Yes, they all have their 4 legs. Count them up. 1, 2, 3, 4, 1, 2, 3, 4, yada, yada, yada. So 3 times 4, that gives us 12. So if we were wanting total legs, there would be 12 legs. We can build a table. Remember yesterday we built tables, especially if they're going to be asking for multiple problems. Number of dogs, 1 dog, 2 dogs, 3 dogs, all the way up to, and this is really where we're going towards. We want to be able to write this for anything. So in this case, if I had 5 dogs, we'd take 5 times 4. 4 dogs, 4 times 4. 3 dogs, 3 times 4, because it's 4 legs, 3 dogs. We want to be able to write it for any number of dogs. In this case, we would be taking in the number of dogs times 4 legs. Well, if it's the number of dogs times 4 legs, we would not write it like this to leave it. Instead, we would write it as 4 in. So we need to make sure that we're paying attention to that convention. Again, 4 in is going to be correct. This is how we would write that, is that 4 in. In times 4 is short 4 in. Okay, so 4 in is the number of legs. 4 times the number of dogs gives us our algebraic expression. Next, we kind of went over this, but just making sure that when we're reading things, 1 times n, it gets transferred to just n. If it is 4 times a, it's 4a. If it is a times 4, remember that English doesn't always transfer perfectly. A times 4 then is going to go back to your 4a, where the number is going to come first. And then a times b is ab. All right. Example number 3. So the first example was multiplying. This one is going to be division. So Dwayne has a rope that's 36 yards long. So we know that it's 36 yards. He's going to cut the rope into pieces that are equal in length. So every time he cuts it, the pieces are equal in length. Can you calculate how long the pieces will be if you know how many pieces he has to cut? So basically what we're doing is we're taking some rope and then we're going to cut it. Depending on how many places we cut it will give us the number of pieces. For example, if I cut it down the middle, it would be cut in half. We would have 2 pieces. In this case, they don't start with 2 pieces. They start with 3. So I'm going to have 3 pieces. So I'm going to take 36 and divide it by 3. When I take 36 divided by 3, I get 12. So each length would be 12. Okay, so in the same sense, if I cut it into 4 pieces, 36 feet long, cut into 4 pieces, I would have an amount of 9. That pattern will continue. Now notice they're choosing easy numbers. 36 divided by 3 is 12. 36 divided by 4 is 9. 36 divided by 8, not an easy number. However, it's doable. 36 divided by 8 is 4.5. So each length would be 4.5 feet or 4.5, or excuse me, yards. 4.5 yards, not feet, yards. That continues all the way up till n. And again, this is where we're going. Once you figure out the rule, and the rule is the same for all of these, the only thing that's differing in all of those is that we're dividing by a different number. In this case, instead of dividing by 4, 8, 9, 18, I want to know for any number of cuts. In that case, we're going to substitute n where the number was the whole time. So 36 divided by n, my conventions tell me that if I'm going to write that, it's written as 36n. Next, you will take a couple minutes. We're going to pause the video. I need you to rewrite each of these expressions using the conventions for multiplication and division. I will give you approximately 2 minutes. You can pause the video now. Okay, hopefully you came up with all of these. This first one, you should have 5a. So first one, you should just have written 5a. Again, I apologize for the handwriting. I can't write on the board, I'm writing on the computer. The next one, a divided by 5, you should have the fraction a over 5. C, 3 divided by n. 3 is the first thing we read, so 3 divided by n. Again, go to that idea of reading it like a book, left to right, top down, 3 divided by n. A times b, we're just dropping that dot, it just becomes a, b. And then that last one, you can do something with this first part. 3 times 4 is 12. So then it's 12 times A. Well, 12 times A we would just write as 12A. So I'm hoping that we have 12A written down, not 3 times 4A or anything else. It's just 12A. So that's that one. Again, we're going to pause for about a minute. I need you to finish this problem as quickly as possible, so you can pause the video now. And then looking at this one, we're plugging in the 6 for the m. So it's 2 times 6 over 6 times, and the n value was 2. I need to see what you plug in, so this should be written on your paper. If it's not written on your paper, then you have a mistake. That then becomes 12 over 12, and 12 over 12 is reducible. Don't leave it as just 12. That should equal 1. So 12 over 12 is then 1. Number 3, you can pause the video now. So Dwayne and Jamal managed a student store. Erasers are sold for 21 cents each. Hopefully we figured this out. What is the cost for 4 erasers? Write an explanation of how you know. Well, because there's 4 each, your explanation needs to be written. It tells you to write it, so make sure that you have it somehow. Mathematically, it would be written as 4 times E, right? Because we're 4 times the erasers. There's 4 erasers times, and actually that's a lie. We shouldn't use E. We should use, hopefully you come up with a better variable, but I'm going to say C. And the reason that I'm going with C, there's 4 erasers, and it's 21 cents each. That then is going to give me my total. So I want that to actually equal, you could write it all the way out, 4 times C equals the total. This is an explanation. It's showing our work. So then we're going to have 4 times 21 cents. You have to be careful there when you multiply by 21 cents. It's not 21, it's 0.21. That is going to represent our total. Now you don't have to write total every single time. You could multiply or write it just as T instead of total. And then 4 times 21 equals 84 cents. Don't write down 84 equals T. 84 equals T would be wrong. You're not spending $84. You're spending 84 cents. You need to have the 0 in front of the 84. Not just a decimal, the 0 needs to be there. So it's 84 T, and then it says use conventions correctly. Write a mathematical expression for the cost of n erasers. So in this case, for n erasers, remember that this is any amount of erasers. Up above, we had 4 erasers. We no longer have 4 erasers. They want it for n erasers. We also, though, established our cost. Our cost happened to be 21 cents. So if we think about this, we're just going to take our cost, C, and change it to the 21 that we now know. And our n, we're going to replace where the 4 was. So that would make n times 0.21. But we know not to write it that way. Instead, we write it the opposite. So it would be 0.21 n equals, oh, and I almost messed up there. They wanted it as an expression. So 0.21 n is an expression for the cost. 21 cents per eraser, number of erasers. Classwork, you're doing the odds only. You can now pause this. Make sure that you check your answers when you are finished. Have a great day.